Let It Flow, the Viscosity Lab. So today we are going to work on two parts of this investigation. They'll be each in separate videos. So let's start with the first part. So a research question is asking us, how does the viscosity, the flow of a moving liquid, of different fluids affect the flow rate of the marble? So what I want you to do right now is to develop your hypothesis, your if-then statement based on your variables. It is a special type of prediction. So if, and you're going to pick a fluid. So our fluids include water, we have our soap, we have oil, and then we have our corn syrup. So if, and you can pick one of those types of fluids, then what do you think is going to happen to the flow rate of the marble as it goes through the graduated cylinder filled with that liquid? Is it going to increase or decrease? Okay. You can see the materials that we're using. The materials are all gathered and set up here for us to utilize. So let's go ahead and complete our MV/IV, our RV/DV, and three controlled variables. Once again, if I'm going too fast, you can go ahead and stop the video and always replay it. So it says, first of all, gather materials, which I have, mass the empty graduated cylinder. So I'm gonna go ahead and mass our graduated cylinder that's empty. And we have 92 grams exactly. So in your data table, we're going to go ahead and write in the second column, mass of empty graduated cylinder, 92 grams. Okay. All right, next, I'm going to use the cylinder, and I'm going to go ahead and pour 100 milliliters into the cylinder with a meniscus reed. Okay, just need to move them. All right, that looks really good for my eye level read. Now it says that we need to mass the graduated cylinder with the water and subtract the mass of the cylinder because we just want the mass of the water. So we have 190.3. So we're going to write mass of G cylinder with the fluid, which is 190.3 grams. So we're going to take this 190.3 minus 92 to find the mass of the fluid or the water. So go ahead and do that with a calculator. We have 100 milliliters. So you're going to take your mass divided by your 100 mils to find your density in grams per milliliter. Okay. So you should fill this out as well. All right, next, our time. So we are going to go ahead and we are going to measure the flow rate. Oh, I'm sorry, we should take our temperature first of the liquid. Probably wait just about 30 seconds and see if it changes at all. And our temperature, I know it's a little bit challenging to see, so I will give you it. It's about 18 degrees Celsius. So 18 degrees Celsius. Okay. All right, so now we're ready for the time. So I'm going to utilize my timer. I'm going to start the time when I release, and then I'm going to stop it when it hits the bottom of the graduated cylinder, meaning the marble. Okay. All right, here we go. So that time was 3.10 seconds. 3.10 seconds. So what you're going to do in order to find the flow rate is you're going to take the volume, 100, divided by 3.110 for milliliters per second. You can round to the nearest tenth. Remember, the nearest tenth is, you would look at this number in the hundredths place to figure if it stays the same, 5 or below, or if it's above 5, then you would round to like 10.3, for example. Okay. All right, so that was the water. That was the water. And flow rate, viscosity. All right, next we're going to go ahead and figure out the oil. The oil. All right, so the oil is right here. This is vegetable oil. 100 mils. Okay. We're going to get our mass. Wow. 168.7. 168.7. So you're going to take this number subtracted by the empty mass of the cylinder to get your mass of the fluid or the oil. Then you're going to take your mass of the fluid divided by 100 to get your density in grams per milliliter. Okay. We're also going to go ahead and take the temperature. And our temperature is about 17 degrees Celsius. Okay. All right, so now we're going to do our rate of flow. So I'm going to take my marble once again. I'm going to start the timer when I release and then stop it when it hits the bottom of the cylinder. So that was 3.32 seconds. 3.32 seconds. So in order to find the flow rate, take your volume, which was 100, divided by 3.32, and you can round to the nearest the nearest tenth using that hundredth number for milliliters per second. All right, next will be the corn syrup. Get my marble out here. All right, so for my corn syrup, I'm going to measure 100. A little bit too much. Okay. All right, so now we will go ahead and figure out the mass of this. So, wow, 234.5 grams. Wow. So, 234.5 grams minus 92 to get the mass of the syrup. Take your mass, divide it by your volume to get your density in grams per milliliter. We'll take the temperature of the syrup. Woohoo! Now it's all sticky. All right, so that was 19 degrees Celsius. And we'll go ahead now and take a look at the marble. Oh boy. I think we all knew that was going to happen. Almost halfway there. Okay, we're getting there. Oh, we're almost there, everybody. All right, and we're good. So, wow. We got, for the time, we got 59.3 seconds. Almost a minute. So, take your 100 divided by 59.3 to figure out your flow rate in milliliters per second. Okay, so the last one that we're gonna do is the dish soap. I just need to get my marble out. So we can reuse that for next time. All right, so dish soap. $100 mils meniscus reed. 179.3 grams minus 92 to get your mass of the dish soap in grams. Take your mass divided by 100 to get your density. Let's take our temperature of the soap. Not a whole lot of difference. These have been out kind of in room temperature when I've been prepping. so 18 degrees Celsius. All right, now we are ready for the marble. And here we go. Okay, so the time for that one was 4.26 seconds. 4.26 seconds. So take 100 divided by 4.26 to find your flow rate. Okay. And that is the first part of the investigation.